So what we're doing is we're going to try x is equal to -1 again, which means x plus 1. We're going to see if x plus 1 is a factor of that guy. And if it is, then we've got a double factor because we already have an x plus 1. And we're just going to take the 2. So same routine. We're going to take the 2, multiply by -1, come up, zigzag all the way up, and find out what the remainder is. The remainder is -2, which means that x plus 1 is not another factor of the original polynomial because it wasn't a factor of this guy, right? We already had it once, it just doesn't occur again. So what happens now is we know that x plus 1 is not going to work because all these guys are positive. If we're multiplying the terms by a positive number, then nothing's going to cancel out. There's no way for us to be able to get a zero remainder. So what we're going to have to do is go into the fractions because the possible factors of this guy, this is 2x cubed plus x squared plus 2x plus 1, right? This is a cubic function. So the possible factors of this are which is plus or minus 1. We've already tried -1, and just looking at it, we know positive 1 is not going to work. So the other two factors that we haven't tried yet are 1/2 and -1/2. Okay, what we're going to do is, try negative x is equal to -1/2. The reason we're going to do that is because we know that these guys are all positive, so there's no way x is equal to 1/2 is going to work out. So what we're going to do is try x is equal to -1/2. Now, I'm going to shift over the camera and we're going to do the synthetic division over here, okay? So what I'm going to do right now is transfer all these numbers up here again and try x is equal to -1/2. So we're trying x is equal to -1/2. The 2 comes straight down, right? 2 times -1/2 is going to be -1. Okay, so I'm just going to go through the zigzags and find out what our remainder is. So what we got is when we go through our zigzags, when you go through the synthetic division, we've got a remainder of 0. So we know that x is equal to -1/2 is a factor of this guy. Therefore, it's the factor of our original polynomial, right? What we have down here, this was x cubed, x squared, x, and the constant. So what we have here, we just divided an x. We just took out an x from an x cubed. So this guy is now an x squared. So this becomes 2x squared plus 0x. It's just a place marker, right? So the next term, the x term is missing. So it's going to be 2x squared plus 2, right? Because that's going to be 0x. So I'm not going to bother writing 0x. And keep in mind, this guy is going to be cross-multiplied up. So 2 goes up here and multiplies the x. And we're going to bring the 1 over. So this guy, the expression for this guy is actually 2x plus 1. So the expression for this guy is 2x plus 1. And what we've done, because we've got a remainder of 0, this guy is a factor of this guy, which means it's a factor of original polynomial. So what we started with was a polynomial to a degree of 5, and we've done 3 successful synthetic divisions of an x term. That means we've kicked something to a power of 5 to something that's a square, that's a quadratic. And that's what we want to do. If we get any polynomials which are higher degree than degree of 2, we're going to keep on doing our synthetic division until we take them down to a quadratic or an expression where we've got 2 things subtracted from each other that we can factor using the difference of squares, right? So what we're trying to do with large polynomials is break them down to a level where we can use the other factoring techniques that we've already talked about. Now keep in mind what I mentioned previously with the warning of whenever you're dividing a fraction, what's going to happen when you rewrite it into this form? What's going to happen is you're going to have to take a look at the quotient, okay, and you're going to have to take out a GCF to make sure that this expression, with this fraction rewritten, this expression is now going to give you your original polynomial back. So this guy is 2x squared plus 2, but what we're going to do is factor out a 2 and dump it, because once we do that, we end up having, an expression where when multiplied by this, it gives us our original term here, because we really don't want to bring negative 1 over 2 over to have x plus a half. That's, you know, it's bad mathematics. It's bad. It's not the best way of expressing factors. You don't want fractions and factors. You want to express them like this, right? You want to get rid of your fractions, because that's sort of the cleanest way of writing something. So this guy here becomes 2x squared plus 2. So we're just going to put brackets around here, take out the 2 and dump it, and that's what we're going to end up with. Is going to be x squared plus 1. So what we have here now is x squared plus 1. That's the polynomial we've gotten down to. Now you can use the quadratic formula trying to factor this, right? But what you're going to end up having is the discriminant for this is going to be a negative. And you can't take the root of a negative number, so you know this guy can't be factored any further. You can also remember that we can subtract two things. We can factor two things subtracted from each other, right? If this was a minus, we could still factor these guys. But two things added together, we can't factor. Okay. Now, what I'm going to do is just show you that the discriminant for this guy is negative. That way, we can't factor. We can't use the quadratic formula. Or we could use the quadratic formula. But in the real number world where we're functioning right now, this guy doesn't have any roots. So the discriminant is b squared minus 4ac. Now, a here, if you write this in the quadratic form, a is equal to 1. B is equal to 0 because we're missing the middle term, we're missing the x term, and c is equal to 1. So I'm just going to do the discriminant over here just to show you that the discriminant is equal to a negative. That means we can't factor it. So if you set b squared minus 4ac, you got 0 squared minus 4 times 1 times 1, and that's just going to be negative 4, right? And negative 4 is negative, it's less than 0, so you're going to have a negative sign inside the root symbol in the quadratic formula. So that means that this guy doesn't have any real roots. It's got complex roots, it's got imaginary roots. But since we're only functioning in the real number realm right now, we're not talking about complex numbers. We're not taking it to that level yet. So this is as far as you can factor this. This is as far as you can go when you're doing your synthetic division. What we're going to do right now is write down our original polynomial over here and write it down in this factored form, because we've completely factored it now, which means we've found all the x-intercepts, and you know, that's as far as we can go with it. Okay, so let's just do a little zoom over and rewrite everything, and that's it. That's as far as it goes. And from there, we could use all the x-intercepts to be able to graph our polynomial, which we will talk about in another series when we get into graphing polynomials more accurately. Okay. So what we have is our original function, right? Our original polynomial, and these are all its factors that we found using synthetic division. X minus 1, x plus 1, 2x plus 1, and x squared plus 1. And this guy was as far as we could go. So this guy up here, in its fully factored form, in the real number realm, is this guy right there. Okay. So if you FOILed all these guys, you would end up getting this original expression here. One way to check to make sure you did everything correctly is take the first terms here, that's an x, multiply the first terms together. So x times x is x squared, times 2x is 2x cubed, times x squared is 2x to the power of 5. That's our first term, right? So that end of it works out fine. And you take the last terms, 1 times 1 times 1 times 1, that just gives you 1. That's our last term there. So that's a really quick way of just checking to make sure that, you know, you've done everything correctly. Hopefully it all works out. And, you know, it's a good idea to do that once you do, you know, if you end up doing a synthetic division, or if you end up factoring a large polynomial like this, because a question like this would be worth a fair bit of marks, right? Because there's a lot of steps involved. So, you know, just take the extra 5 seconds, 10 seconds that it takes to check your answer, just to make sure that you ended up getting, you know, hopefully you didn't make any mistakes in the middle terms, but you ended up getting the right answer, right? And that just gives you some more self-confidence when you find that, you got the first term right and you got the last term right. Hopefully all the middle terms are correct as well, and the odds are they will be if you got the first and the last term right, okay? Again, this is the way you do factor large polynomials. You got to use synthetic division. You start off, possible factors of the last guy divided by possible factors of the first guy. Always start off with, the lowest possible numbers first, the lowest possible factors first. Make sure everything is in descending order. Make sure you put zeros for place markers for any missing x terms, right? And the one important thing to keep in mind is if you end up having fractions where you have to rewrite them, cross multiply them up and move everything over, when you get down to your quotient, take a look at it. You may have to take out a GCF and dump it to make sure you're still consistent with your original polynomial. So I hope you enjoyed the series that we did in the skate park. There was a fair bit of info here. As I said initially, there was going to be a lot of information coming your way, and there was a lot of information coming your way. So hopefully you were able to process most of it anyway. And whatever you're having problems with, hopefully we can clear that up when we go ahead and start doing some examples, solving some equations and graphing them. And we're definitely done with the skate park. It's a great skate park. We may come back to it later on sometime in the future, but we're going to go into the city and see what we can find there and do some work back in the city. Okay. See you guys in the next videos. Bye for now.